All right, so in this video, we're going to look at section 1.4, which is talking about rewriting equations and formulas. When we rewrite an equation or formula, we're solving for a specific variable within that equation or within that specific formula. All right, so let's start off with this example 1, which is similar to what you'll see in the textbook. This one says solve 5x subtract 4y equals to 8 for the variable y. All right, so let's go ahead and try to do this one. You'll use the same steps that we did for solving an equation. So remember, we're going to do order of operations backwards. But remember, we're going to treat terms as one entity, so there's no need to separate that. We're just going to go ahead and solve for y by simply moving the other variables and other items to the other side of the equation. Now, because there's a negative here, it will be easier to move the negative 4y to the other side and make it a positive. It will save you a lot of trouble in the long run. So let's go ahead and do that. You could do the other and move the 5x and do it that way, but it's just like getting to your school or to some grocery store or something. You can choose different routes at different times as long as you do it correctly. So remember, we're going to do the opposite operation of the thing we want to move with the same number. And in this case, we're using the whole term as the number. And what we do to one side of the equation, we do to the other. All right, so these will cancel out, and you're going to be left with 5x is equal to 8 plus 4y. Now I'm just going to rewrite it because we learned that addition is associative, so I can put the 4y first, and that will set me up for having the y by itself. So we have 4y, and the 8 is positive, so 4y plus 8. Then we can move the 8 across because we want the y by itself. And so we do the opposite operation, the same number, and what we do to one side of the equation, do to the other. And so these 8's will cancel out, and we will have on the left side, 5x subtract 8 equals to 4y. Now we just need to get the y by itself, and the operation that's holding that term together, as we learned before, is multiplication. So we do the opposite operation, which is division, the same number that I want to remove, and what I do to one side of the equation, I do to the other. Now I have the choice of dividing everything by 4, or what I can do is just divide each term by 4. Really the choice is yours at times, but sometimes based off of the question, you might have to do one or the other. So for this one, I'm just going to do individual. So I'll divide the 5x by 4 and the negative 8 by 4. And so on the right side, the 4's will cancel, and we're left with y on the right side. You can rearrange it if you want. And on the left side, we have 5 over 4 x subtract 8 divided by 4 is 2. And so now we have an equation. And you'll learn about this equation more. You're going to learn, if you haven't already, from Algebra 1, this is what we call slope-intercept form of a linear equation. And there we have it. That's our answer. All right, so let's move on to another type of problem. In this one, very similar again to the book. And so you can try to do different ones that are similar. Given the equation, x plus xy equals to 5, find the value of y when x equals to negative 1. And this one here should say y equals to 3. So just make sure you change that to y equals to 3 if you copy this down. All right, so how do we go about solving for y? So we're solving for y on this one. And you could either rewrite this and then go ahead and solve for y. So we want the y by itself, and we want to start with the weaker operation, since here we see a single term and then a double term that's being connected, of course, by multiplication. So what we can do here is move the x over, so we can subtract x on both sides, as the y is already on the left and it's positive. So these will cancel. And on the left side, we're just left with x times y equals to 5 subtract x. And that's subtract a little bit slanted, but 5 subtract x. And then what we want to do is get that y by itself. Because that's multiplication, we will divide by the same term or variable or number that we're trying to get rid of, which in this case is the x, which will cancel and leave you just with y. And what you do to one side, you do to the other. So you end up with y equals to 5 subtract x divided by x. Oh, I was right the first time. I got a bit confused. These are two different ones, so this should still be x. Forgive me for that. So they want you to do two different things here. I need to make sure I read the question carefully so I can erase that part. So if you did change that, my bad. I'm sorry for that, but go ahead and continue with x equals to 3. So we're going to do two different ones. I'll change the color so that they stand out. First, we're going to do it when x equals to -1. So we're going to substitute that in there to see what y is. Y is equal to 5 subtract -1. And you could have just put it in straight in that equation, but based off of this example, and I mean the original equation, you could substitute in there and try to find, but that takes a lot of work. So once we already have it set up this way, we can go ahead and just solve for this equation. Remember, we're going to have, when we have two negatives like that, it turns to a positive. So we're going to have y equals to 5 plus 1 over -1. That's going to be y equals to 6 over -1. And y equals to 6 divided by -1 is the same as just -6. So when x equals to -1, what we get is that when x equals -1, we get y equals to -6. All right, let's try it now with x equals to +3. So when x equals to +3, using the formula we now have, or the equation we now have, we substitute our 3 in there. We have 5 subtract 3 divided by 3. And that's going to be 5 subtract 3 is 2. And we're done. Y equals to 2/3 when x equals to 3. All right, so that way we can rearrange a formula, solving for y, and then utilizing the substitution principle to evaluate that variable, y, when we have the different values of x. All right, let's move on to another question. Example 3 is talking about equations with more than one variable. That means that you're going to have an equation where you might have x and y, or z and x and y and t, or something like that. So let's go ahead and look at this question. It says you are organizing a concert. Your plan is to have only adult and child tickets. Write an equation with more than one variable that represents the revenue from the concert. So we could use R for revenue. How many variables are in the equation? So this is kind of a two-step equation here, two-step process rather. They want you to find an equation that represents the revenue, and then they want you to actually state how many variables you have from that equation. Don't forget that second part. All right, so let's look at it. Our revenue, you can always start off with a variable model. Our revenue is going to be equal to the price of the adult ticket. All right, so how much it costs. If an adult ticket is $50, then you're going to make $50 per adult. But how many adult tickets do you have? So you know from the first part that you're going to have the price of the adult ticket. I'm just going to put price adult, just for space sake, times the number. And I'm just writing this way just for space on my thing. And I'm having a little trouble with this pen. So let me try it again. I'm going to use the cross product. That's easier than a dot. Actually, you know what? Let's use parentheses. So we're going to say the price of the adult ticket, in parentheses, times the number of adult tickets, right? So if you have 100 tickets and $50, then you know how much money you're going to make. So number of adult tickets plus the price of a child ticket times the number of child tickets. So I'm just put CT. All right, so we have the price of the adult ticket times the number of adult tickets plus the price of the child tickets plus the number of child tickets. Times the number, I said plus, times the number of child tickets. All right, so that's going to give our revenue. Now the thing is, they don't give us any numbers in here, so now we just need to actually rewrite it in terms of variables. So we're going to have R equals to, and you can choose whatever variable that you want. If you look at the book, sometimes people use subscripts to represent variables, and sometimes people just use letters. The key is so that your letters stand out. So if you say the price of the adult ticket, if you just say capital A, you could do that. Or you can say P1 for price. And for the number of adult tickets, you could have capital A. So we can assign letters to them. So for the price of the adult ticket, we could use P and P sub 1. Number of adult tickets, I'm just going to use capital A. Number of price of child tickets, we could say that's the second price. So sub 2, P sub 2. And then the number of child tickets, we can use capital C. And I'm going to write the big letters first. So multiplication is associative, so we can rewrite them this way. And it just looks a little bit neater when you have the capital letter first. So AP1 plus CP2. And that will give us R, which is our revenue. All right, and so remember that's multiplication in between the two. And so how many variables do we have? Well, that's 1, 2, 3, 4, 5. So we have 5 variables. All right, and so that's how you would do a question like that. And I believe the next question builds on that. Yes, it does. So we're going to use our R equals to AP1 plus CP2 for the next one. So we have R equals to the adult ticket times the price of the adult ticket plus the amount of child tickets times the price of the child tickets. Okay, so now that we have that formula, let's go ahead with the second question, or the second part of this. For the concert in example 3, your goal is to sell $45,000 in tickets. You plan to charge $45.50 per adult and expect to sell 625 adult tickets. You need to determine what to charge for child tickets. How much should you charge per child if you expect to sell 500 child tickets, 600 child tickets, or 700 child tickets? Now, there are two ways you can do this. You can either substitute all your values in there and then work your way down to the answer, or you can rewrite the formula so that it's set up so that you have the variable that you want as the single variable. That is the single subject that is all by itself. So it's like solving for y like we did previously. So which variable represents how much you would charge? Well, remember, we chose our capital C to be the amount of child tickets and P2 to be the price. So that means we could solve for P2, and then we will have a formula that represents the charge per child. And then we would just have to solve based off of the variables that are given. So you can always rewrite your variables. It's good to have them there. One of the biggest mistakes that people make is just mixing up what the variables should be, and sometimes we can forget it. So sometimes it's good to rewrite what they are. So our R represents our revenue. Our A is the number of adult tickets. What else we have? Our P1 represented the price of the adult. Our big C represented the number of child tickets. And our P2, P sub 2, represented the price of child tickets. And that's what we want to see there. We're looking for how much should we charge. So let's solve for P2. So the first thing we want to remove is the weaker operation. And because we're going to treat this as one entity, we're going to treat that as a term. We're going to move that whole thing by subtraction because it's a positive term there. So we're going to move that to the other side. And remember, we're going to use the order of operations using the inverse of each one to move things to the other side of the equation. So we're going to subtract A times P sub 1 and bring it to the other side. And what you do to one side, you do to the other. All right, so this side cancels and you're left with R subtract A. I'm just going to put a dot there just so it really stands out. And it wants to disappear on me. So R subtract A times P1 is going to be equal to our big C times P sub 2. So to get P2 by itself, because that's multiplication, we will divide by the item that we're trying to move, the variable. And what we do to one side, we do to the other. So the whole thing gets divided by C. These C's cancel, and now we have an equation or a formula that will actually help us to find what the price of the child ticket should be. So we can either rewrite this one more time so we can see it clearly. R subtract A times P1. You can put the dot or parentheses in there if it's a little bit confusing. All divided by C. is equal to P sub 2. And remember, you can really change, you can use whatever variable you want to represent what the price is or the adult ticket. All right, so let's go ahead and work it out for the first one, $500. So our revenue is our goal here. We want it to be 45,000. And so we're going to have 45,000. It's going to be equal to, sorry, I'm using the old formula. We're supposed to use the updated formula there. So 45,000 subtract is what I should have written because we're using the one down here now. So 45,000 subtract the adult ticket. And that big A represents the number, so that's 625 times the price of the adult tickets, which was $45.50. Now, it's very possible you could do this without algebra, but it's always good to know how to build these up, because as we get higher up to different types of functions, which are harder to do without algebra, you have the basic gist of how to write these equations. Now just bear with me, I'm having a hard time writing 0 there and erasing it. You might see the video trying to erase it, and it just won't erase. So I'm just have to write around that, and so there we go, and then it erased for me. All right, so we have 625 times 45 and 50 cents, all divided by the number of child tickets, and that was the expectation of 500. Right, and that would all equal to what we should expect to charge a child, which was P2. All right, so the beauty of Algebra 2 is that you can use your calculator. You can decide to work that out by hand, or you can work it out on the calculator. So that's 45,000, subtract 625 times 4550, all divided by 500. Okay, so that's going to give us $33, and you're going to have to round it. It was the original number was 33.125, but since we're dealing with currency, we're going to have to round that to 2 decimal places. And so with 5 there, that's going to round it up to 3. So that's going to be $33.13 that we will charge for a child ticket if we want to reach those expectations listed in the question. So our final answer there would be, and you would want to write this out in a verbal statement. So you can say, I would expect to sell $33. Sorry, I would expect to have the price of a child ticket to be $33.13. Right, I don't really have the room there. It's just the drawback of writing on the computer screen. All right, so make sure you write a verbal statement whenever dealing with a verbal problem-solving question. Now, they also wanted us to do it with 600 and 700, and all you would need to do is substitute the 600 here and then the 700 there, so take in turns. I'm just going to put it straight in the calculator and just show you what those ones would be. So for the first one, and we can number them, so and I'll change the color as well. So this is the first one for $600, and then I'll just show you what the answer would be if you substituted in for $600. So in your calculator, if you already have it there, depending on your calculator, you could just go in and change the 500 to 600, and that's going to go down in price because you have more tickets. And so if you do it for $600, you should get $27.60. No need to round because the third digit is a 4, and that would be P2 if you did it for $600 in the red. And then the last one, let's change that color to green, $700. And we'll just call that the third option. Remember, you just replace the 500 in the formula, in the purple formula, to 700 on the bottom, in the denominator. And if you do that, you would get $23.66. And there's no need to round that last digit because the third digit is a 0. So $22.66 would be the P2 for $700, as indicated by the circled different colors. All right, so that's how you would do example 4. Now the other thing is there are popular formulas for this course. You have it in the textbook that you can refer to. And these formulas, sometimes it's good to know them by heart, depending on what type of test you might be open to take. Some entrance exams, colleges, and etc., some expect you to know these by heart. So it would be good to familiarize yourself with them. But these are very popular formulas that you will often have to solve for a different variable. Sometimes you have to take the distance formula, distance equals to rate time formula, and solve for t. Or you might be given simple interest and asked to solve for p, which is the principal. With temperature, you are asked to either rewrite the formula in Fahrenheit or Celsius based off how it's given to you, and vice versa. Very popular formulas here: the area of a rectangle and the perimeter of a rectangle, of course, the area of a triangle, and each of those you might be asked to solve for a different variable. And that's why we want to know how to do it. So if you were looking for the height of a triangle or the base of the triangle given the area, could you find it? And so these are the different things that we're going to do in the area of a trapezoid. So let's go ahead and see what we're going to do here. We're going to actually rewrite one of the common formulas. In your book's a different one, and so you could familiarize yourself there. Now this is the formula for finding the temperature in degrees Fahrenheit. If you were given Celsius, let's say you had 20 degrees Celsius, then how much would that be in Fahrenheit? Right? You substitute in there and it would give you your Fahrenheit. Well, what if you wanted to rearrange the formula so that when you were given Fahrenheit, you can find the Celsius? Well, you can use your understanding of solving a formula for the other variable. And so let's go ahead and do that. We have F, which is Fahrenheit, is equal to 9/5 of C plus 32. And we want C to be our subject of the formula. We want it to be the one that's by itself now. So we're going to start with the weaker operation, which is the addition, which is adding 32. And we'll start with the opposite operation and the same number so that they cancel. And what you do to one side of the equation, do to the other. Right, so now we're left with F subtract 32 is equal to 9/5 C. And you have two options here. You can divide the C by 9/5, or just remember that dividing a fraction by a fraction is the same as multiplying that fraction by its reciprocal. So in order to cancel that, I can actually multiply this by 5/9. And if I do that, what will happen is diagonal cancellation. The 5 and the 5 cancels. The 9 and the 9 cancels, leaving me with just C on the right side. And what we do to one side of the equation, we do to the other. And because we're multiplying that whole side, we're multiplying it as a quantity. So it's really important to have the parentheses in there. If not, you end up only multiplying the F. So over here we have 9/5. Oh, sorry, this should be 5/9. All right, so let's rewrite that to 5/9 on the left side. And you can either leave it like this, 5/9 times the quantity F subtract 32, or you can distribute the 5/9 into the quantity. And if you do that 5/9 times F, remember multiply each one, you have 5/9 times F, subtract 5/9 times 32. Now you can go ahead and simplify that all together, or you can just rewrite that 5/9 times 32. Now the preference is that you simplify it at times, or just leave it in its quantity form because it's easier to use. So we have 5 times 32, and if you divide that by 9, you get about 17.7777. It's a repeating decimal. So we have 160 over 9. Now that's not the popular way, so most times you see the Celsius formula is given in this format, 5 over 9 times F subtract 32. All right, and so that's how you can do that one, turning it into the Celsius formula. And I'm just rewriting that 5. Okay, so that's how you can do any formula, and we will practice some more, of course. Okay, so we're on example 6 now, and we're going to apply a common formula. So this one says you have 55 feet of fencing with which to enclose a rectangular garden. So express the garden's area in terms of its length only. So because they want it in area, we can utilize the two formulas that we talked about before. And because perimeter is 2L plus 2W, and area is equal to length times width of a rectangular garden, and we want the terms, the garden in area, we can substitute the perimeter formula into the area formula by solving for the W in the perimeter. So if we do that, we can subtract the 2L, and what we do to one side, we do to the other, and that cancels out. We have P subtract 2L is equal to 2W, and then divide both sides by 2. Right, and so once we do that, we have W is equal to P subtract 2L all divided by 2. And because we want this to be expressed in terms of area, we can now substitute that into the area formula, substituting the W for our W we just found in the perimeter. Now this will allow us to only have the variable L for length. So we have L times P subtract 2L all divided by 2. And now you could substitute that 55 in there. It seems like that's what the question would want. But you have now a generic formula. This formula can also be equivalent to distributing your L into that quantity so that you have P times L subtract 2L squared, giving you a quadratic equation, which area represents. And you see that later on in like chapter 4 or 5. All right, so what we have here is our two formulas. If we needed to put the value of 55 in there, we have L times 55 subtract 2L over 2. And you can also substitute it in here, having for your perimeter 55L subtract 2L squared, all divided by 2. But there you have it. We have now a formula for area of this garden in terms of its length only.